coder. I taking an advanced coding class, and our assignment is to teach you about what we're learning. So learn to teach and teach to learn, I suppose. Um, so the main things that we're going to be going over in this tutorial video, I suppose, are going to be one, coroutines. Then we're going to do some delegates, the multicasting of those delegates. We're going to see how we can use some Lambda expressions. The simple, like a very simple explanation of how generics and templating are used in coding, and we're also going to go over some multithreading and its very simple form. Very complex, but you do want to get to know how to use it. So what we're going to look at first is coroutines. So coroutines, how I think about it is a tape recorder of a sort, or a VHS tape. So you have your film, and then you have your two wheels, and that VHS tape can go on for a specific amount of time, or it can go on forever, depending on how much film you have. But when you're initializing your coroutine and you're using it, you tend to use it for a set amount of time, pause it, use it for a set amount, pause it. So it'd be like watching a movie on that VHS tape, where your film is basically your functions and what you're trying to do inside of your coroutine. So here I have a really simple, so there's a lot of different things here, but we're just going to be focusing, this is a coroutine. You can usually see that it's a coroutine by the I enumerator. You'll see that before every coroutine. And then in every coroutine, you're going to find these yield functions. These yields return new, yield return null. These allow the coroutine to know when to stop and when to wait, when to pause, basically, for my VHS tape analogy. Basically, where you want to pause a movie and what do you want to wait on it to do, kind of thing. So to initialize an enumerator, like I said, you add this or initialize the coroutine, and you add this I enumerator in front of it, and then you have your yield function to basically round it out. That's your return. So here it's a super simple. I have a button click and a Lambda expression. So you can write it like this normally, where it's just your public void activate. You put your function into between the two curly brackets. You call whatever you're trying to do. But you can write it like this. This is what with these arrow was equal and a less than sign. To basically point to what you're trying to do inside that function. So instead of writing the two curly brackets, you just write in one line. You could say that it's efficient. You could also say that it's just lazy. Depends on your opinion. So in this coroutine, I have it adding random stuff basically that I just typed. That just came to my mind when I was coding. So I have a string, I have a transform, I have an integer, and I have a string. And you're like, well, how are all these different things going into the same place? And that's because it's a generic. So it's a generic list, I guess you would say, or a generic function. So this T signalizes that it's a template or generic. And then this T is then replaced. So instead of, add to inventory, where this would be a T here, it passes your string and then whatever you're trying to pass for this. So it's very similar to, I guess a list is a generic, but this is how you would basically set up a list, right? So you have your string and whatever you're trying to put into it, or an integer, or an object, or anything. The generics just allow you to write the function once and reuse it for other variables. So it's a very good way to basically modularize your code, so you don't have to write it so much. It's not so messy. It's not long because you're copying code. Um, so in this coroutine, I had to have it adding, random and then random string, and then it waits for a couple of seconds, and then adds a transform, waits for a couple of seconds, adds an integer, and it waits for a couple of seconds, and then once it adds this final string, it yield return nulls, which basically just stops the coroutine. So that's just your stop button. So basically, if you had a VHS player, when you click stop, it ejects it. So you usually don't want to do that. Um, or I guess it's more like your power button. Uh, but uh, there's little holes in my analogy, but that's how it works. So here I'll show you how it works. Just a little game that I'm working on, but I'm gonna be using it to teach y'all. So um, you can see down here that the first thing goes through. You see that it has a little time between it, and then it adds it, and then again there's time between each of the things being added to the inventory. Um, so that's how you would use coroutines. You can use it like that, or you use coroutines for literally everything, especially in video game programming. So you have your cooldowns, you have your wait times, you have your attack rate. There's so many things that you could use a coroutine for. Like in my research of learning the more advanced aspects of coroutines, you could even use your coroutines to replace your update functions within Unity or any program really, where it's just a controlled function that you have control over. So take for instance an AI or something. If it was in another room, you don't really necessarily need to start the update function on that character until the character is actually in render distance. So you're saving a lot of processing power when you use coroutines in an efficient manner. So you're basically just controlling that update function, which allows it to be more efficient. So that's a little advanced technique. I didn't really do this in mine. What I did in mine, I used a couple of enumerator or coroutines to basically get that original like Pokemon text box kind of thing, where it's just like and the text comes up. So I'll show that now. So basically, how I used this coroutine was instead of just printing the entirety of the string at one time, it waits for each character in that string. So, um, so this is my type sentence, and you can see that like I have my string here, and then for each character in my sentence, it puts it into a character array and then prints uh, the the character, but then it waits and then it restarts that coroutine. So that typing speed is a variable that you can change within your editor. I'm eventually gonna have it to where like in Pokemon where I can have like the fast, the normals, or slow speed. I'm gonna have that to where you can change your typing speed, um, and that just allows the coroutine to play over and over again, but it waits um, for the typing speed to be done. And you see how there's yield return new, which means it's starting a new coroutine after I wait for the typing speed, instead of yield return null, which would completely end my coroutine. Um, and so you can stop all your coroutines here. I do this in my end dialog, so where, a lot of people don't really care about the lore of the game, even though, you have a lore team spending hours and hours creating lore for your game. They just skip the dialogue. They're like, I just want to shoot people. But that's so I would stop the coroutine, I clear my sentences, and the animator goes away for my text box. Um, let's go to delegates. So we covered generics as well as the Lambda expressions in here. Just to review, this is a Lambda, and I'm passing my inventory as my generic. Um, so yeah, so let's move on to delegates. So I originally wrote this this code before I really knew about delegates, which now that now that I know it, I wish I knew it like way before. There's a lot of things that you're trying to program opening up a UI or like an inventory where there's items in it, and you have to like one, open up your inventory, two, make sure that all your items are in ABC order, and then two, populate the list for your inventory, and then make sure that all the images are displaying properly in the inventory slot. Like all of those things, you wish you could just like call instead of like calling it individually in each of the codes that reference your inventory. Um, so what delegates allow you to do is basically assign your function to a variable, and then you can call that variable later on. So here I just have it. My delegate is do player setup. So in my player setup, I need my dialog box, and I need my rigid body, and I need my controller. So I was originally in my start function, I just called all three of these, um, which looks messy, but with delegates I can kind of make it shorter and sweeter. Especially if I needed to ever reference my player character, I could just do like player setup and go from there. But a delegate allows you to basically, this is how you would assign it. So you basically assign a function kind of like a function or a variable, and then you assign that function to a variable here, and then from there you can reference that and add in your other functions that you want it to go in sequential order. You can also minus, so eventually for uh, processing, you'll want to remove said functions after you're done with it. Um, so uh, so that's how you could use delegates. You can use delegates in a lot of other ways too. Just anything that you would normally need to call a function in a sequential order, it allows you to basically preset it up so you don't have to write so much code, um, which is really nice, and it's a very intricate thing, and I definitely want to use it some more. So the last thing we're gonna do is threading. And if you were paying attention to my console, you would have seen that there was A and B there. This is a super simple threading example. I figured that it'd be the easiest to teach somebody how threading exists in a very simple. I mean, I got it off a tutorial, so it's obviously not my code, but I I modified it to work in Unity. So two simple for loops printing A and B. However, instead of printing it just normally with the start function, I'm printing it with the start function and a thread. So now there's two separate processes. They're not parallel processes. They are, I forget the word for it, but they're basically they're sequential. I think is the word. To where it's operating like a kind of like a seesaw or like a catch and throw, where one works and then the other one works, and then one works and the other one works. So I'll show that in my console. So it's collapsed, but here I'll uncollapse it, and you can see that you can see here that a lot of it is B, and then but there's some parts where you see your A and your B, and then you see A and then B. So you can see that where the processing is of the thread and just the normal start function are both processing, but they're not processing at the same time, and the time's not long enough to see, but like milliseconds, they're processing at different times. Um, so I mean, a lot of these threadings are used, and they're using a lot of like data data management. So when you're having a lot of variables made, or you need something to keep running while you're doing something in the background, so you can have one thread focus on, managing your inputs, and then you can have one managing your UI kind of thing. Um, so it just allows you to like delegate different processing powers to different purposes. Um, However, in Unity, it can cause a lot of problems, and just normally it can cause a lot of problems because um, when you think about it, if you try to, so if your two variables are null and you're changing it, but in one thread but not in the other, and the other thread's trying to run a mathematical equation with those variables you're changing in another thread, it'll cause it to really not work. Because you just have two null variables, or sometimes you'll have one variable and a null variable, or if you had like zeros, then sometimes you may be getting, or if you set your variables in a division equation to zero, then you would have sometimes a variable filling in for zero in your denominator, but if you had a zero in your denominator, you're dividing by zero, and it causes an error, and it causes your system to crash. Um, so there's definitely a lot of ways you can make your thread safe. I didn't write them in here, but you can. There's different functions that allow you to lock your threads, which just basically, I, I work in Telegram, so we basically put people into call queues. So it's first come first serve. So you get assigned a number, and you call, and you're waiting for 5 minutes, and the other person's been waiting for six. So the person with 6 minute called first says they get to go into the next operator. Um, so I think of it like that. So your threads are basically your callers, and you're trying to get to your operator. When you lock your function, it allows that one thread to get to that function or that variable before another thread does. So that's how you can make your thread safe. Um, when your threads are unsafe, it's just like I said, where we have two threads trying to do a process, and it one process needs the variables from the other one. And if it's not referencing correctly, then it's not going to work. Um, Now I think I've gone over the time limit, but thank you for listening to my tutorial and watching my very minimal game.